Hello everyone, welcome to OCC Massive Math session. Today's objective is trigonometry. Trigonometric function of angles. So we're going to dive into three objectives. Part one, we're going to talk about evaluating trigonometric function as any angle. And objective two, trigonometric identity. And then part two of the videos is we're going to find the areas of a triangles. All right, objective one, evaluating trigonometric functions at any angle. We want to evaluate the following angles, and we want it in the exact answer. So that means you might use your calculator to check your answer, but you should be able to show work how you come up with the exact answer. Okay, so tangent of 7 pi divided by 3. We can rewrite it as tangent of 6 pi divided by 3 plus pi divided by 3. We can split it apart like that. Well, 6 pi over 3, that's 2 pi plus pi over 3. Now, on a unit circle, because it's a circle, right? You start out with pi over 3. So say pi over 3. No, that's pi over 6. Pi over 3 right here. And then you go another 2 pi. You mean you go another 360 degree. So that means you go around counterclockwise 360 degree. And because it's 360 degree, you're going back where you started, right? You go back where you started. So this actually, the 2 pi plus pi over 3 is the same thing as tangent of pi over 3. Well, if you look up on the unit circle, pi over 3 is, tangent of pi over 3 is square root of 3. It's a first quadrant, so it should be positive. So difficult to make this ruler straight. All right. Okay. 1b. I want to find the value of psi of negative pi over 3. Maybe I should have put the parenthesis here to look at more friendly, I guess. If you look at the unit circle, size of pi over 3 is in the first quadrant. So let me erase this. So side of pi over 3 is right there in the first quadrant. You go counterclockwise to get to that angles, right? If it's negative angle, you go clockwise. So instead of going like that, you go back like this. So this will be negative pi over 3. That's a theta, right? The angle would be negative pi over 3. All right. Okay, now at pi over 3, my psi or y value is root 3 over 2. Okay, so 1/2 comma root 3 over 2. That's my x and my y. Because it's the same thing, it's symmetric over the x-axis. It is the same value, same absolute values. All you do is just change the size, right? So here you're gonna have 1/2 and then negative root 3 over 2. Right now I just have a negative length for y because it's in the fourth quadrant. Or you can look up the unit circle. So this equal to negative root 3 over 2. Okay. Cotangent of 495 degrees. Again, it's kind of similar to part A, where you break it up into two angles. So here I'm going to break it up into 360 degrees plus 135. It's 360 and 135 add up together is 495. And again, same argument. You start out with 135 and then you go once around, so that's 360 degrees. You go and you're gonna end up back where you started. So you end up at the same starting point, which is 135, right? So this is exactly, this is equal to 135 degrees. That's what they meant by running around in a circle. Mean that you go back to where you started. If you look up on the unit circle, cotangent of 135 degrees is -1. Last one for problem 1. I want to find the value of secant of -pi/4. Now, on the unit circle, I don't have the value for secant, but we know that secant is the reciprocal of cosine, right? So I can, let me write this in, so note. So I know that cosine theta is the reciprocal of secant theta. Right, so secant theta is the reciprocal of cosine theta. So this one, I can rewrite it as what? Instead of secant of -pi/4, I can write it as cosine of -pi/4. So what is the cosine of -pi/4? Erase that. If you look at the unit circle, again, negative angle, you go clockwise, right? So -pi/4 is this one, right in the middle of the fourth quadrant. So -pi/4. At this angle, your cosine value, your x value is still positive, right? It's still positive, and it is the same thing with pi/4 up here, right? Same thing. So it should be what, √2/2. This one should be, your x value should be √2/2. So cosine of -pi/4 is actually √2/2. Which is 2/√2. I assume that you guys know how to do complex fraction. And if it square root of 2, I can rewrite. If you want to simplify, you can do like this. Square root of 2 is the same thing as square root of 2 square over square root of 2, right? One of the square root of 2 cancel, so left it, which is square root of 2. All right. Objective 2 is trigonometric identities. It's number 1 is express tangent theta in terms of sine theta, where theta is in quadrant 2. Maybe we use this piece later. Not now, but right now I want to write a tangent theta in terms of sine theta. Right? So tangent equals something on the right hand side is all the sine function, all of them. And so I can start out like this. When I think of tangent theta, I automatically think of sine over cosine. But I cannot do much about sine and cosine, right? But if I square them, I can have the trig identity, right? So if I square both sides, or square everybody, the reason I'm doing this because there's a trig identity, the Pythagorean theorem, sine squared theta plus cosine squared theta, you know it, equal 1, right? So again, remember, we want to write tangent theta in terms of sine. So all the term that is not sine, we're going to try to convert it into sine. So the top is sine theta squared. So far, it looks okay. I'm going to leave it like that because at least it's in side term. Now for the bottom, I'm going to transform the cosine theta into sine term using the Pythagorean theorem. So this one right here, if you solve for cosine squared theta is equal 1 minus sine squared theta. So the denominator is going to replace with 1 minus sine squared theta. Let me rewrite this so it's neatly. So tangent squared theta, so far we done, is equal sine squared theta over 1 minus sine squared theta. I want tangent theta, not tangent square theta. So I'm going to take square root both sides. Oops. And again, mathematically, when you take a square root, you should have plus or minus. Okay. All right. On the left-hand side, tangent square, so square root of tangent square theta is just tangent theta. For the top, square root of sine square theta is sine square theta. And the bottom is, just keep it like that, square root of 1 minus sine square theta. For the side, do I pick positive or negative? Well, that's when we're going to use that piece of information I underline in blue. Right? We know that theta is in quadrant second. So quadrant second has negative x, but positive y. So the tangent is y over x, so it's going to be negative. Right? So must pick negative. Okay. Number 2, given tangent theta equal 2/3 and theta is in quadrant 3, 5 cosine theta. Is in quadrant 3. So I'm going to draw a right triangle in quadrant 3. That's theta. Okay, given tangent theta right here is 2/3. Well, tangent is positive, makes sense, right? Because on the quadrant 3, x and y both negative. You have negative on the top, negative on the bottom. It should cancel out. So tangent is positive. Tangent is y over x. So y is 2 and x is 3. So y is 2 and x is 3. All we have to do is find the radius r. Right? So naturally, we use the Pythagorean theorem. 2 squared plus 2 squared plus 3 squared equal r squared. 4 plus 9 or 13 r squared, or r equal root 13. We can do plus or minus, but we know that the radius can't be negative, it's just length. So let's kind of ignore that part. All right, we want cosine of theta. Remember, we want cosine of theta. Cosine of theta. So we know that cosine of theta equal x over r. Well, x is, I'm sorry, -3, -2. I'm so sorry. What about that part? X is -3, and r is, we just solved for it, which is root 13, and we're done. If you want to rationalize it, you can, but it's not an algebra class, so I think I'm gonna box my answer there. Number 3 is pretty much the same like number 2. You draw a right triangle in quadrant 4, and then they give you secant of theta, right? Maybe I'll do a little bit and then you guys fill out the rest, right? So this one, again, first thing first, draw your right triangle. Quadrant 4, so it looks like that. Let's see, secant theta, well, we cannot express things in secant term, so we're gonna change the secant of theta into cosine, right? So secant of theta is the same thing as what 1 over cosine theta, and is say that is equal to 2. I want to solve for cosine theta, so let me erase that part so I can do my equation thing. All right, I want to bring cosine theta to the top, so multiply both sides by cosine theta over 1, right? And then distribute the cosine theta into both sides. On the left-hand side is cancel, so it's just 1 equal to cosine theta. So cosine theta equal what? 1/2. Or maybe I have a better way of explaining this. Let me give you another explanation. So if secant is equal to 2, or better yet, 2 over 1, because cosine of theta is the reciprocal of secant theta, all you do is just flip it, right? So cosine of theta is 1 over 2. Maybe that's a better explanation. Whichever, how you like to understand it is fine. But the goal here is we're going to try to fill out all these 6 trigonometric functions. Okay, so cosine is 1/2. So that means cosine is adjacent over hypotenuse. Adjacent is your x. So x is 1. And the radius is 2. And it is positive 1 because quadrant 4 has positive x. We need to find the y. Right? We need to find this Pythagorean theorem. So we know that 1 squared plus y squared equal 2 squared. Y squared equal, so 1 plus y squared equal 4. Therefore, y squared equal, subtract 1 both sides, equal 3. Y equal root 3 or negative root 3? Negative, right? Because in the full quadrant. So y is negative root 3. All right, you have all those, you have x, y, and r. You can go ahead and fill out those six trigonometric functions. All right, good luck. Thank you for listening. Bye-bye.